Welcome to this deep dive. Today, we're digging into some really crucial climate research. It was highlighted in a pretty compelling Guardian article.
Yeah, I saw that one.
We've pulled this source material together to really understand some new records, not in the air, interestingly, but deep down in the oceans.
Right. And why that matters so much for, global heating overall.
Exactly.
And the headline finding, it's really quite stark. The oceans have just hit their highest temperatures ever recorded.
Highest ever.
And this isn't like a one-off weather thing. It fits this pattern, this relentless warming trend we've been seeing build for years now.
And here's the thing that really jumps out from the source. The core reason we have to pay attention to the oceans.
Yeah.
It's because they absorb something like, over 90% of the extra heat, the heat trapped by greenhouse gases.
Over 90%.
Yeah.
That's right. I mean, think about that. They're essentially the planet's main buffer, a giant heat sink.
A huge heat sink.
Exactly. And this specific record temperature, it's detailed in a new study published in Advances in Atmospheric Sciences.
Okay.
It's by a team of, I think, 20 climate scientists.
20 scientists.
Right. And what makes it feel pretty solid is that they've pulled together temperature data from oceans all over the world. We're talking measurements going back decades, some even to the 1950s.
Decades of data. And the scale of the energy we're talking about, honestly, it's hard to get your head around until you see the analogies they use in the source.
It really is.
Zetajoules.
Zetajoules, a one with, 21 zeros?
Yeah, just mind-boggling numbers. The research suggests Earth soaked up around 20 zetajoules of extra heat in just one recent year.
20 zetajoules. And the article puts that in perspective.
Yeah.
It says it's like switching on 630 billion standard hair dryers.
Billion, with a B.
And leaving them running nonstop, day and night, for almost a whole year.
Wow, that hairdryer analogy, it really hits home, doesn't it? It shows this huge energy imbalance that our activities have, created.
It does. And the crucial point the source makes is this isn't just some abstract number. It connects directly to things that affect you, that affect everyone.
Like the weather.
Exactly. The weather patterns you experience,
Yeah.
the intensity of storms, that kind of thing.
Right. So our mission today for this deep dive is basically to unpack this source material together. Understand the key findings, why they matter so much, and, what it all means for you listening in.
Sounds good. Let's get into it.
Yeah.
So this team, the scientists, they do acknowledge that, temperatures naturally vary year to year.
Sure, there are fluctuations.
Of course. But they really stress looking at the long-term trend. Is there a consistent, ongoing pattern underneath all that yearly noise?
And digging into those decades of measurements they found, well, it's unambiguous, isn't it?
Completely. Ocean warming has been continuous
Yeah.
for as long as we've had good data.
And it's not stopping. The source suggests it's accelerating.
Yes. And what's really compelling, something the article highlights, is how they checked their work.
Oh, right. They compared it.
Yeah, they didn't just rely on their own analysis. They compared their findings with data from other major groups, like NOAA, the U.S. National Oceanic and Atmospheric Administration.
Okay, NOAA. Big player.
Right. And NOAA's independent data showed a remarkably similar pattern. They also ranked that same recent year as the hottest on record for the oceans.
So different groups, same conclusion.
Pretty much. The exact number for, say, just that 1 year's warming might differ slightly depending on how different teams analyze the data.
Yeah.
But that overall long-term upward trend, it's perfectly aligned.
That kind of agreement, that corroboration, it's powerful. Really boosts your confidence in the finding, doesn't it?
Absolutely. It tells you this isn't just some quirk one team found. It's a real phenomenon that multiple independent analyses are picking up.
Okay, so the oceans are definitely warming. But you might be thinking, I don't live in the ocean.
Right. Why should this matter directly to me?
Yeah. And this is where the source really connects the dots.
The answer is, it's simple but also profound. The oceans fundamentally drive Earth's weather.
Right. I mean, think about it. Almost 70% of the planet is water.
A huge surface area.
So when that massive area warms up, it obviously heats the air right above it.
That's part one. But maybe even more critical is evaporation. Warmer water evaporates more easily. More moisture gets pushed into the atmosphere.
You feel that, don't you? That thick, humid air on a really hot day versus a cold, dry day.
Exactly. That's evaporation doing its thing on a massive scale. So by warming the air and loading it with more moisture, the oceans are basically controlling the two key ingredients for weather, temperature and humidity.
And boom, that's where it hits us. directly. The article is pretty clear how these warmer oceans are fueling more powerful, more erratic weather. It mentions Cyclone Yasa in the South Pacific.
Yeah, a monster storm, one of the most intense recorded there.
And we're seeing places get hammered with heavier rain, more flooding.
But it's not just about more water everywhere. That's a key point the source makes.
Okay.
This same ocean warming can also make other regions much, much drier.
The other side of the coin.
Precisely. It contributes to more intense heat waves, longer and worse droughts, and those awful wildfire seasons. Think Australia, the western U.S.
Yeah, we've certainly seen those. So there's a direct line, the research shows, from the ocean's temperature to the extreme weather you might see outside your window.
That's the critical link. And based on these trends, the physics of it all, the expectation laid out in the article is, well, pretty sobering.
More records likely to be broken.
Routinely, yes. And unfortunately, that the weather you experience will likely continue to get stranger, more extreme. And the source does note this comes with very real expected costs. Human lives, infrastructure damage.
Yeah.
However, it doesn't just end on a completely bleak note. The article does mention, the potential to still turn this ship around.
Okay, so there's still some hope expressed.
A degree of hope, yes.
Yeah.
That changes in leadership, global policy.
Yeah.
That these could lead to more concerted, effective action on the climate crisis.
It's definitely a complex picture painted by this material.
Absolutely. So wrapping up this deep dive, it's really shown us that these ocean temperature records, they aren't just abstract numbers on a chart.
No, they represent the bulk, the vast majority of the extra heat humans have added to the planet.
Making them this incredibly powerful, fundamental signal of how our climate system is shifting.
And we've seen that direct line the research draws, warmer oceans leading to the increasingly intense, unpredictable weather you're seeing globally.
Yeah, the heavier storms and floods in some areas.
And the deeper droughts and worse wildfires in others.
And the fact that, as the source points out, different independent research groups are all confirming these same warming trends.
Right, that really adds weight.
It adds significant confidence. And it reinforces the expectation that this continues unless there's major global action.
So here's maybe a final thought for you to chew on based on that sheer scale of heat we discussed. Given that the oceans have already soaked up energy equivalent to, hundreds of billions of hair dryers running nonstop for years.
An incredible amount of stored energy.
Think about the momentum, the immense momentum that stored heat gives the climate system. How does that huge reservoir of warmth affect the timeline, the scale of the challenges we face, even if, hypothetically, we stopped all emissions tomorrow?
That's a really crucial question.
What does that sheer thermal mass imply about the need, the absolute necessity for adaptation, for building resilience in our communities right alongside trying to cut emissions?
Yeah, it definitely suggests adaptation isn't just a nice to have, it's essential. A lot to think about there.